All right, thanks. Welcome to an introductory class to organic chemistry. This class is presented by Dr. Tache Abel. From an introductory point of view, organic chemistry is a branch of chemistry that focuses on the study of carbon-containing compounds, which are essential to life and as well found in all living organisms. It is also important to note that these compounds are known for their diverse structures and properties. This allows them to form the basis of countless molecules that exist in nature, ranging from simple hydrocarbons to complex biomolecules, such as proteins and DNA. An example of such simple hydrocarbons are described below. We have alkanes with a single bond, as well as alkanes having a carbon-to-carbon double bond, and also alkynes having a carbon-to-carbon triple bond. Likewise, we also have under the hydrocarbon, aromatic hydrocarbons as described. For the protein constituent, we have two proteins undergoing condensation reaction to produce a larger protein component. And this protein component are formed from actually amino acids. And the unique bond that exists in protein molecules is known as peptide bonds. Right. So what are the key concepts in organic chemistry? The first is carbon as the backbone. Carbon atoms serve as the central element in organic molecule, forming strong covalent bonds with other atoms. It can form this bond also within other carbon atoms by itself or with other elements such as hydrogen, oxygen, nitrogen, and other elements as well. However, the ability of carbon to form stable bonds with a variety of atoms allows for the creation of an enormous range of compounds. For instance, to describe what you just said, based on carbon-to-carbon bonds formed, we have the simple illustration as earlier discussed, single bonds, double bonds, as well as triple bonds. There are also other instances carbon can also form covalent bonds with other elements. This is also described in the bond formed between carbon and oxygen as reflected in CO2. And also the bond formed between carbon and chlorine elements as well. Furthermore, there is also a key concept in organic chemistry known as functional groups. Functional groups are specific arrangements of atoms within organic molecules that give rise to characteristics, chemical reactions, and properties. Examples of these functional groups include the following. Number one, hydroxyl, denoted as OH. It also has a representation in a skeletal form as O bonding to H as well as to R, where the R represents a longer chain functionality. And OH can be indicated in the molecule as described, where we have two carbon connecting to an OH. And this have a representative name as ethanol. Number two example of functional group is the carbonyl representative, described as C double bonding to oxygen. That's carbon double bonding to oxygen. This can be represented in diverse forms. It can exist as aldehydes, ketones, carboxylic acids, amides, esters, and acyl chloride. The difference among this functionality on the carbonyl functional groups. For the aldehydes, you have one hydrogen, one replaceable hydrogen, carrying the carbonyl compound as well. But for the ketones, the replaceable hydrogen has already been replaced by an alkyl functional group, which is also another R. So you can see the difference between aldehydes and ketones is that aldehydes have a replaceable hydrogen, whereas ketones already has this hydrogen being replaced by an alkyl functionality. What about carboxylic acid? For the carboxylic acid, the position of the replaceable hydrogen has an additional oxygen. So that means the carbonyl carbon, which is C double bond oxygen, is connected to OH with an alkyl R. And also you have the description of amide. The amide have the carbonyl carbon connecting to nitrogen as well as connecting to the second alkyl representative. What about the esters? The esters have a carbonyl carbon connecting to an oxygen that carries an alkyl functionality. The acyl chloride has the carbonyl carbon linking to a chlorine representative here as well. So look at this carefully. The unique identity here, it's a carbon double bonding to an oxygen. But the difference is in the substituent. So carefully study the substituent to be able to differentiate between each of these classes. Number three, we have the amino functional group. This is represented as nitrogen bonded to two hydrogen representation, as well as an alkyl R. Note, functional groups is responsible for the reactivity and the behavior of organic molecules. That means the reaction, the conditions, the state, the ability to exist under certain conditions for every organic molecule is a function of the presence of a particular functional group. Right. Furthermore, the next key concept in organic chemistry is isomerism. We all know that organic molecules often exist as isomers. So what is isomers? Isomers are compounds with the same molecular formula, but different structural arrangements or special orientations. What does it mean? It means that molecules can have the same formula, but the way they are arranged differs. Such kind of molecules are known to be isomers. This is a typical example that isomerism can be grouped into the following. Number one, it could be structural. When a molecule exists in terms of structural isomers, what it denotes is that the different bonding arrangement is the significant property that is observed among such isomers. For example, you will say, this is butane. It has 4 carbon atoms. Now, these carbon atoms can be rearranged. In the second compound here, the structure of this normal butane is quite different from this other structure. So the implication is that though they have the same formula, but their structures are different. They have the same number of carbon, equal number of hydrogen. Number 2 types of isomer is the geometric isomers. They have different special arrangements around double bonds. That means they can exist either in the cis formation or the trans formation. Now look at these both structures. You can discover that the alkyl group R1 and R2 are found on the same plane above the double bond, whereas hydrogen is found below the double bond. In such case, where the functionality are on same side, it is referred to as cis. But in the other case where you have the trans, you find out that R1 and R2 are on vertical positions, as well as the H component of it. In that case, it exists in a transformation. Number 3 type of isomer is the stereoisomers. These isomers display different special arrangements without changing the connectivity of the atoms. For instance, we have two different molecules, but they have the same constituent. But the difference is the molecule on the left-hand side and that on the right-hand side are just like a direct opposite, meaning they both have, they are like mirror images of each other. So something might have caused this change. The position of bromine, Br, in the structure on the left-hand side, you can find bromine, Br, on the right-hand side for the other structure. This shows that there is a rotation. So such kind of changes that brings about rearrangement, atoms changing position with a constant arrangement of the connectivity displays the possibility of stereoisomers. All right. As we begin to round up for this class today, there are also very important key concepts such as reaction mechanisms, organic chemistry also focusing on how reaction occurs, because this will study how bonds are formed as well as how they are broken during a chemical transformation. Reaction mechanism helps to predict the outcome of chemical reactions and design synthetic pathways for the production of desired organic compounds. And also we have synthesis and analysis. Chemists over the years have used synthesis of new organic compounds for diverse applications in medicine, agriculture, material science, and other fields. There are also very vital methods for the analysis and characterization of organic molecules using various techniques. These include spectroscopy, chromatography, and mass spectroscopy. We also have mass nuclear magnetic resonance, a lot of them. However, organic chemistry plays a crucial role in understanding the chemistry of life, drug discovery, material science, environmental science, and many other areas of scientific research and technological development. Therefore, on a final note, today, keep a reflection on this. You can't fly with an eagle without the will to ascend. Thanks so much. See you in the next class. Thank you.